So I did not show you how to find the EBM, and the reason why is because this calculator step right here takes out the need for finding the EBM. But I'm looking at your WebAssign, and there's a couple times when they ask you to find the error bound mean. So I want to show you how to find that real quick. So the error bound mean is found by z alpha over 2 times sigma divided by the square root of n. So let me tell you real quick what this z alpha over 2 means. I actually kind of showed you this earlier on in this picture right here. In this picture right here that I outlined in green, I said that the confidence level is equal to 1 minus alpha. So basically, if my confidence level is 90%, I can say 100% minus 100% minus my 0.9 will give me 0.1. So we're going to call 0.1 alpha. And if I take alpha, I told you it was 10%, right? And if I take alpha and divide it by 2, so I took that 0.1 and divided it by 2, I got 0.05 or 5% and 5%. That's my lower tail and my upper tail. That's what the alpha over 2 means. So this basically is the z-score for that alpha over 2, the lower tail. So so in order to find that, we would use our inverse norm. In the example up here, right here, in the stats exam scores, let's just say we needed to find the EBM. Again, we did not have to find the EBM because of this nice little calculator function. And I'm more focused on you being able to calculate this, the lower bound and the upper bound for our confidence interval. But let me just show you real quick on how to find that EBM if that were necessary in one of your problems. So in that example above, we said our mean was 68. We said our standard deviation was 3, and we said our sample size was 36. So that means that the EBM would be z of alpha over 2 times standard deviation divided by the square root of n. So we know the standard deviation, we know n. We need to find z of alpha over 2. We also knew that our confidence level, which is important, we have to know that, was 90%. So we could say alpha will be equal to 1 minus 0.9, which is 0.1. And then this is alpha. We could divide it by 2, 0.1. So we'll say alpha over 2 is equal to 0.1 divided by 2. That means that alpha over 2 will be equal to 0.05. So if we're looking at that picture, again, same picture as before. This is our alpha over 2, and this is our alpha over 2. I guess, hold on, let me take that part off. That's the z-score of alpha over 2. The area under the curve, honestly, is what's the alpha. Oh, darn it. Here we go. Sorry about that, guys. I'm still on the eraser. There we go. There's our standard curve again. All right, so I want to switch colors. The area under the curve is really the alpha over 2 and alpha over 2. And underneath here, this is our confidence level. So in this case, it was 90%. So we said that this one is 5%, and this one is 5%, because altogether they have to add up to be 100%. So notice that this one here is 0.05, and this one here is 95. Wait. So what we're going to do is we're going to do the inverse norm. So let's do inverse norm of 0.9501. So using our calculator, inverse norm, I'll do it with you so we take about the same time, I hope, 0.95. We're putting a mean of 0 and standard deviation of 1. That would give us 1.64. Let's round to thousandths, 3 digits, 4, so that'll be 5. So that is how we find, that is our EBM. Our EBM will be that 1.645. So what we would do is we would take that 68. Remember we said our confidence interval is our mean, which I think our mean was 68, right? 68 minus 1.645, and the upper interval was 68 plus 1.645, and it actually ends up being exactly what that calculator gave us before, which again, I would totally use the 8225. I would totally use, if I'm looking for the confidence interval, I would use this calculator method up here, this one here. But if you needed to find the EBM, I wanted to make sure that I showed you how to find that EBM so that you could answer those